In this example, we're going to simplify the square root of 54, x to the 4th, y to the 7th, z to the 3rd. To do so, under a square root, we have to look for any perfect square factors of the factors underneath. So in this case, let's look at the number first. 54 can be split as 2 times 27. Neither of those are perfect squares, but 27 is divisible as 3 times 9. And we know that 9 is a perfect square factor. Multiplying the 2 and 3 back together, we can say that underneath our radical, we currently have, for the number, 9 times 6. We'll also note that x to the 4th is already a perfect square factor. The square root of x to the 4th would be x to the 2nd. Y to the 7th is not a perfect square factor, but y to the 7th is divisible as y to the 6th times y to the 1st. Remember, we add exponents in this situation. And z to the 3rd is the same thing as z squared times z. Underneath the square root, we can factor out any perfect square factors. That is, for numbers, 9 is a perfect square factor. The square root of 9 is 3. X to the 4th is a perfect square. We know we have perfect squares when the exponent is even. In this case, we divide that even exponent by 2, which is our index, and we get x squared. Y to the 6th, also even. We divide 6 by 2, we get y to the 3rd. And z squared is also divisible by 2. That's z to the 1st. And so our remaining factors stay under the radical, and we have 6y z. Nothing else can be reduced out of our radical, and so we're done.